Okay, so I'm just going to record myself going through the unit review so that as you're preparing for your test, whether it be on Friday or next Monday, you have something to kind of refer to. So the first part of our unit was drawing diagrams. So all I'm doing here is whatever it describes, that's what I'm drawing. So a line, what's important about that word is that it has to have arrows on both sides. And then it's passing through both points C and D. Okay. The next one, we haven't really seen in a setup like this. It says draw a visual of segment addition, then include the equation. So what this means is just give an example of what segment addition might look like. So maybe I have A, B, and C, and they're all in a segment. And so the equation piece is then saying, okay, AB plus BC equals AC. That's what segment addition, that's what an equation for segment addition would look like. 3, aligned segments, so no arrows, but points on each end from R to T. A is the midpoint of segment BG. So I'm gonna have a segment BG, and A is going to be in the middle. Okay, and I'm marking that it's the same length on both sides. A line segment from E to F, so let's start there. E to F is bisected. Bisected means cut in half, so in the middle, by line M. So right in the middle, there's line M cutting that segment into 2 equal parts, bisecting it. Okay, so that's just drawing some diagrams. The bottom half of this page gives you a diagram and asks you to answer a few questions. So what's the intersection point of plane P? So here's my plane, and line BN. So line BN is the line that's shooting through that plane, and it's intersecting that plane at point B. I have too many pens out, several there we go, point B. What points are collinear to point B? So here's point B. I have on this line, point F and point M, and on a different line, point N. Okay, so F and M are collinear to B on this line L, little L here, and N is collinear to B on this other line. Name all points that are coplanar, so on the same plane as point F. So on the same plane as point F would be point B, point M, and then over here, point O. They are all on the same plane as point F. Point N is not on that plane. Name a point that is not coplanar with point M. Well, the only point that's not on this plane is N. So the not coplanar point would be point N. How many possible ways can you label the line FB? So here's the line FB, and it has 3 points on it. And so there's several ways that I can label this line. I can call it line BF. I can flip those letters around. I could call it FM or MF. I could call it BM or MB. So just to kind of jog your memory there, we only use 2 points on this line. So I can go F to B, B to F, F to M, or M to F, B to M, or M to B, but I never use all 3 points to label that line. So including this as one, there's 6 ways that I can label this line. But again, I can only use 2 points. We never use 3, just as a reminder there. Okay. Then it goes to some equation work. So here it tells me that J is the midpoint of this segment, which then allows me to set up my equation, because if I know from C to J is 9x plus 1, and from J to T is 2x plus 15, well, knowing that this is the midpoint tells me that this length is the same as that length. So I can set up my equation, putting those parts equal to each other, and then solve for x, subtract 1, and x equals 2. Now that I know what x is, I can find various parts of this segment. So first it asks for CJ, which is here, C to J. And so CJ, if I plug in 2 for X, gives me 19. Then it asks for CT, which is this whole length from C to T. Well, I could either plug in here, but I know that this is the midpoint. So if this is 19 units, then this is 19 units. And the whole segment would be 19 plus 19 for 38 units all the way across, okay? And then on 12, we need to know what type of angle. This is from notes 8, okay? So because these angles are creating a straight line, I know that this entire angle here is 180 degrees. That's a supplementary angle pair or a linear pair or a straight angle, whatever word we want to use. But I know if two angles give me a straight line, that adds up to 180 degrees. That's where my equation comes from. So I can say that 3x plus 2 plus x plus 10 is equal to 180 degrees. And now I'm just solving my equation. So 4x plus 12 equals 180, or 4x equals 168. And divide by 4, and I get 42 for my value of x. Once I know what x is, I can find, oh, it didn't give us, I remember this from last semester. I didn't actually put the points on here. So let's see. Let's call this A, B, C, and this C, B, D. Okay. So A, B, C, to find the measure of this angle, we have 3x plus 2, and we know x is 42. So substituting 42 in for x is going to give me 126 or 128 degrees. And then I could just subtract from 180. It should work that I should just be able to subtract from 180 to get the other angle. Or I can plug in, so I have x plus 10 here, substituting in, I know x is 42, gives me 52 degrees for my other angle. And then they should add up to 180, which they do. Okay, so once I find x, just substituting it in, and obviously there were supposed to be points there. Wasn't supposed to be that point. Okay, this is again using angle relationship. So APC, which is this angle, is equal to what other angle? And so again, that's using notes 8, where we know that vertical angles are congruent. So APC would be equal in measure to DP, angle DPB. And this is using angle addition. DPB, which is here, plus BPC, which is here, there are two possible things I would accept here. One is that this angle plus this angle gives me angle DPC. That adding these two parts give me this larger angle. Or you can see that this angle plus this angle gives me a straight line. So the other answer I would accept there is saying that they equal 180. Because they give me a straight line. APF, so that's, I use a different color, this angle here. And FPB is this angle here. R, and that is at looking for that straight line, are supplementary. Or you could say equal to 180. You could say are adjacent angles, okay, but it's looking for the fact that those two make up a line. I'm not going to worry about 16. It's just, there's too many points on this document to worry about angle pairs that are congruent here. You could pull your vertical angles out, but we're not going to have something like that we need to worry about for now. Okay, let's flip this page. Then it goes through a whole lot of segment and angle addition. So what I'm going to do is I'm going to talk about the setup of one of these. And then I'm going to pause the video and get all the answers down, and I'll just kind of talk through them to save us some time. So we've done a whole lot of segment and angle addition. Here we have a segment, right? And I know that this part plus this part, 2x plus 30 plus 5, has to be equal to the whole length of the segment there. And then I would go and solve from there. So that's our setup. That part plus part equals the whole segment. Now for our angles, skipping down to 19, we need to label the diagram first. So the way that we do that, following what it tells us here. So RST, R to S to T, that's the whole angle. RST is 152 plus 2x. Then I have BST, BST from here to here to here is 58 degrees. And last I have RSB. So RSB is going to be this angle here, is x plus 94. Once I have that labeled, then I can do the same setup where I have part plus part equals the whole angle. And I would solve from there. Part plus part equals whole. So I'm going to pause the video. I'm going to solve all of these, and then I'll start the video again, and you can check your work. Okay, so just checking answers here. The segment should be pretty straightforward with the setup. It's already labeled. Part plus part equals the whole segment. And I helped you set up 19. This one is a little bit weird because you get x equals 0 when you solve. And then 20, so check your setup here. So here's part, and the whole angle CDE is 167. In solving, we get 7 there. You would be able to use a calculator on your test or quiz. Okay, now let's move on to really the part 2 stuff. So those if-then statements and proofs. So hypothesis and conclusion. On the checkouts for this, what some of us were missing is that, and I still give you credit for it, but technically the hypothesis and the conclusion don't contain the if and the then. So we have this if-then statement. The hypothesis is just the piece after it. So the hypothesis is an angle is 150 degrees. The conclusion is it is an obtuse angle. Okay, so it doesn't have the if or the then included when I write what the hypothesis and conclusion are. Converse, right, meaning I'm flipping it. So our converse would be if, and I'm going to just kind of change the words a little bit to make it make sense. So I'm going to put an angle still. If an angle is obtuse, or is an obtuse angle, then it is 150 degrees. So here's my converse, and we have to decide if it's true or false. So written this way, it's fine. Angle's 150, then it's obtuse. Here, if an angle is obtuse, then it's 150. That's going to be false because there are several other obtuse angles. It doesn't necessarily mean that it's 150. So it says, if it's false, give a counter. If it's true, write a by conditional. So since it's false, we're going to give a counter. And on the checkout, I wrote some notes back for some of you on this. A counter example is a specific example. So I can't just say an obtuse angle is any angle over 90. That's too general. It's just generally why it's not true. Okay, a counter example is a specific example. So maybe I say a 151 degree angle is also obtuse. Okay, specific example. Now on our next one, so again, hypothesis not including the if is x equals 25. And the conclusion, not including the then, the square root of x then is 5. Converse, flip-flopping that, if the square root of x equals 5, then x equals 25. Now that's still true, even written the other way around, that if the square root of x is 5, then x must equal 25. So because it is true, we're going to write a biconditional. Biconditional is when we connect hypothesis and conclusion with the words if and only if. So that's going to go in the middle. I'm just going to take hypothesis and conclusion and connect that. X equals 25 if and only if the square root of X equals 5. That's how I write my biconditional. So here's my hypothesis, conclusion. Could have flipped it around. Could have put this at the beginning and the X equals 25 at the end, as long as these two statements are connected with if and only if in some way. Okay. All right, now we're moving into proof land. So for our proofs, this is just asking for, it would be like if in my proof I had statements and reasons, it's saying, if this was above, if I had X plus 7 equals 20, if that was my given, what would be the next statement? And my next statement would be X equals 13. Okay, so if this was true, my conclusion would be X equals 13, and my justification would be subtraction. Okay, so it's really saying, given this, what would be the next row of your proof? That's what it's asking for here. Conclusion, meaning statement, justification, meaning reason. Okay, if this is true, then I can conclude this because of subtraction. I subtracted 7 from both sides. So same here. If I am given this, which I'm going to write a diagram for this one. I have A, B, C, and I know that ray BX bisects them, bisects, which means cut in half. My conclusion and what I can say from being given this information is that this angle is the same as this angle. That angle ABX is equal to angle CBX, because that's the definition of bisect. Okay. Similar here, if I have a segment XY, and I know that B is the midpoint of it, what I can conclude from that is that this half, XB, is equal to YB, because that is the definition of midpoint. Okay? So given that information, what can you conclude, and what's the reason you can conclude it? So we have a couple of proofs here. One is an algebra proof, and the other is a geometry proof. So for my algebra proof, first of all, for all of these, we should not, so if the points on this proof, I would say are 8 points. There's 4 points here and 4 points here. You should always get the first 2 points in this algebra proof where I write the given. The other step we should always get is that the last step is the proof. Okay, we have to go from here to here. Now I have, look, 1, 2, 3 points, and I just have to fill in the rest. So from this statement, I would say the next thing that I would like to say is that 4x equals, oh, we don't even need a third step, do we? We have an extra step here. 4x equals 32. And the reason I can say that is I know I can add 7 on both sides. So this is addition. And then from here to here, I don't need this third step. I can say then x equals 8 by division. That's just probably a typo on my part. Okay, real quick proof. If this is true, then that's true. If that's true, then this is true by division. Okay. Now, our geometry proof. So starting with the givens, AB equals DE given. I'm going to mark that. AB and DE are the same length. We have another given here. So it says given again, that's BC equals EF. BC equals EF. So remember with my givens, I want to mark that. I don't like the way this proof is written. I'm going to rearrange this. Then here we have segment addition. So for segment addition, I'm going to say that AB plus BC equals AC, and that DE plus EF equals DF. Okay, that's segment addition. So I know these are given to me. And then visual tells me that I have segments broken into parts. So here's my parts equals that whole segment, parts equals my whole segment. And then I'll just move this down. So that would be what I would write as step 3. And then step 4, then I want to say this, AB plus BC equals DE plus EF. Now this is a confusing statement in the way that it feels different than addition in an algebra proof. So what I'm doing is I'm saying this is the same amount. So I can add the same amount to both sides of an equation and it doesn't change it. Okay, so because BC and EF are the same amount, it's like saying 5 equals 5. I can add 5 to both sides of my equation. It's still going to keep it equal. So we're using the addition property to say if this is equivalent amounts, I can add it to both sides of my equation and not change anything. And the reason we want to do that is because AB and BC equals AC. That's how we get here. And that's how we get AC. DE and EF equal DF. And what we did there was substitution, right? We said if this is equal to that, we can substitute it in. And if this is equal to that, we can substitute it in. Okay, but I tend to go, I don't put addition before segment addition because I go givens, and then what can I see from my diagram? And now how can I put it together to get where I want to get? Okay. Then our last page here, I know this is a long review, goes to our notes number 8, our angle properties. So first, we have a table. So angle, complement, and supplement, where we know the complement equals 90 degrees with our angle and our supplement equals 180 degrees. The trick here is we always have to go from this column. So if my angle is 32, I go from angle to the complement. The complement, so the angle that would give me 90 degrees with 32 degrees is going to be 58 degrees. 32 plus 58 equals 90. But now what students want to do is go from here to here, and we don't. We're going, okay, so this is the complement of my angle, the supplement of my angle. So again, what angle with 32 degrees gives me 180? So that's how I need to think about it. And you can use, I'm going to use a calculator because my brain, it's too early in the morning for me to want to do this table mental math guys. So my supplement here is 148. Both complement and supplement are brought back to the original angle. So then the trick is that if I'm given the complement, first I need to find my angle. Okay, so what angle added to 61 gives me 90? That's going to be 29 degrees. And then this supplement is saying what angle with the 29 degrees gives me 180, which is going to be 150. I guess my mental math's all right, 151. Okay. So same idea here. If I'm given the supplement, first I need to find my angle. So to find my angle, I'm just saying, well, 180 take away 123 is giving me 57 degrees. These are supplementary. Then from 57 degrees, the complement would be 33 degrees. That these two add up to 90, these add up to 180. These add up to 180, these add up to 90, but it all goes back to this angle. So if my angle is 46, then my complement is 44 degrees. And if my angle is 46, then my supplement is 134 degrees. Okay. So filling in that table. Then we have angle relationships. So we had 3 angle relationships on notes number 8. One is complementary angles that equal 90 degrees. The other were our supplementary angles, which create a line, equal 180. And then the last angle relationship are our vertical angles, which are equal to each other. Okay. So our first example, these are vertical angles. They're equal to each other. So my equation setup is that 2x plus 29 is equal to 5x plus 20. Okay, so really I need to just identify which one do I have to get my equation and then solve from there. So I'm going to just go through and talk about the setups, and then we'll check our answers after. Looking at the second example, that's this. It's a 90-degree angle. So my setup is that this part of the angle plus this part of the angle has to equal 90. And I solve for x from there. On our next example, these angles are creating a line. That's this situation. So I know that, so these are complementary angles. These are supplementary angles. So I know that 6x plus 19 plus x has to add up to 180. Okay, it's creating a line. This part plus this part has to add up to 180. And I'd solve from there. On the fourth example, this is giving me vertical angles, which are equal. It's giving me two pairs of vertical angles. So I have vertical angles here. And I know 64 equals 48 plus x, and that will allow me to solve for x. And then I have vertical angles here, where I know that 8y plus 36 is equal to 14y minus 24. So I have vertical here and vertical there. I can't use the line that's created because one's an x and one's a y, so that's not going to work. I could, I guess, here. I could use it here to solve for y. I could use the fact that that adds up to 180 and creates a line. Okay, and then we solve from there. Our last two here, it gives me 90 degrees here, which means it has to be perpendicular on both sides. This plus this is complementary angles. 6x plus 1 plus 47 has to add up to 90 degrees. Our last example creates a line. These two angles create a line. So 5x plus 10 plus 6x plus 5 has to add up to 180. So the trick here is figuring out which angle relationship do I have. Are they equal to each other, equal to 90, or equal to 180? And then from there, it's just solving. So I'm going to pause the video and I'm going to solve all of these, and then I'll start the video again and just kind of go through the answers. Okay, so let's just go through the answers here. I'd help to leave the setup. So just kind of checking, making sure you get the correct answers for your variables. You can use a calculator. Okay, and that's our review. So gold cohort, you're taking your test on Friday. We'll go over the quiz and we'll talk about this review in class Thursday and Friday as well. And then blue cohort, you're going to take it Monday. If you're remote, then you should plan on taking it Monday as well.